thing I'm going to do right now is to invite our first guest lecturer, keynote speaker, Professor Alexander Gegov, and that's from University of Portsmouth. He has got 30 minutes to present, and then you will be able to ask him questions as well. So please welcome our guest, please.
Good morning, everyone, and welcome to this great conference, and I hope you enjoy it. I'd like to thank the organizers first for inviting me to give this lecture. I'm from the School of Computing, the Faculty of Technology at the University of Portsmouth, which is not too far away from here, and today I'll be talking about artificial intelligence, recent developments, and future perspectives. I have to say that this presentation will have a lot of breadth, but not too much depth because I don't have too much time. I'll try to do it within 20 minutes and leave about 10 minutes for questions and discussion. But the aims of these presentations are to introduce basic concepts, approaches, and techniques in AI. I'll be using this acronym throughout the presentation, to highlight benchmark examples, case studies, and application areas for AI, to discuss new developments, future potential, and main challenges for AI, and to facilitate general understanding of AI and its use. Let me start with a definition for natural intelligence, and this ability to perceive or infer information and retain it as knowledge by means of logic, understanding, self-awareness, learning, reasoning, planning, creativity, critical thinking, and/or problem solving. And I'll give a very brief definition of artificial intelligence as well, which is the ability of machines to demonstrate aspects of intelligence as the ones above. I just want to make a note that depending on the number of natural intelligence aspects which are implemented in a particular machine and the extent to which they're implemented, we may distinguish between different types of AI. It could be more basic or more advanced. Sometimes it depends on how you understand natural intelligence aspects as to whether you think that there is AI in a particular system or not. And many academic communities are still arguing about the boundaries of AI. What is human intelligence? It's the ability to learn from experience, adapt to changes, grasp concepts, and apply knowledge. And human intelligence has been the main inspiration source and role model for AI. Of course, human intelligence is considered to be the most sophisticated type of natural intelligence. And I would like to highlight three intelligence, a term that you may not have come across before, but which I believe is very important. Computational intelligence is a term that combines what we mean by approaches for implementing human intelligence in AI. And it's been the main driving force behind current success of artificial intelligence. Because these days I can't imagine any AI which is not implemented on a computer program, as a computer algorithm, on a computational platform. So the three main strands of computational intelligence are fuzzy systems, which are very good for reasoning and inference, neural networks, which are capable of learning adaptation, and evolutionary algorithms, which are very good for search and optimization. And just to say a few words about AI in the community, and generally speaking, some of you may have come across software tools, environments like MATLAB, Python, and R that have specialized toolboxes for the implementation of different types of AI and machine learning algorithms, but also some major companies like Amazon, Google, and IBM and others have their tools which are freely accessible for anyone who'd like to experience what AI is and wants to use AI in their everyday work or other activities. I'd like to mention a few top journals in the area of AI, which are all published by the IEEE Computational Intelligence Society. These in particular pattern analysis and machine intelligence, fuzzy systems, transactions, they're all transactions, neural networks and learning systems, and evolutionary computation. And all these journals, they have an impact factor which is over 10, which is a very high impact factor for journals in the area of computing. Also, I'd like to mention two fairly big events, which are big not only in terms of the number of participants, but also in terms of their ranking and their high profile, and these in particular, the IEEE Symposium Series in Computational Intelligence, SSCI, and the IEEE World Congress in Computational Intelligence, WCCI. This was the first part of my presentation, which was more general. Now I'll move on to the second one, which will go into a little bit more detail, and I will look at some related topics such as cybernetics and complex systems, big data, machine learning, deep learning and deep models, and then I'll discuss very briefly things like performance evaluation, application areas and case studies, current limitations, possible improvements and main challenges, recent results, and research collaborators, and finally I'll mention some authors, research monographs, edited books, and some popular textbooks. AI is not existing in vacuum. There is, overlap with other areas of research that have been around for much longer. And one of these areas, and some of these areas actually have helped AI develop in more quickly. So I'd like to discuss some of these areas. The first one being cybernetics, which is a transdisciplinary approach for exploring regulatory systems which complements AI. And from all these bullet points on this slide, you can see different kind of attributes, especially the first two, like learning, adaptation, cognition, connectivity, communication, and emergence are very typical for AI as well. The other two, the last two bullet points, we talk about subsystems, interactions, common goals, feedback loops, control algorithms, and reference trajectories, are more specific to the area of cybernetics. So there's really this kind of symbiosis between the two of these, and this is just an example for an aircraft flight control context on this slide, which is very typical of cybernetics with actual speed, reference speed, speed error, and engine power. Another area that has overlap with AI is the area of complex systems, which are usually considered to be regulatory and other systems composed of many interacting components, like what you see on this graph, which represents a network of airports, and with all these kind of links representing services between these airports. And here we can distinguish between quantitative complexity in terms of number and size elements, or qualitative complexity in terms of noise or disturbances. And we can also identify different attributes of complexity like dimensionality, connectivity, uncertainty, and non-linearity. And quite often, these attributes of complexity could pose problems when we decide to do modeling in terms of efficiency, transparency, accuracy, and feasibility. Cybernetics and complex systems have been used in AI mainly in the context of cyborgs, robots, sensors with different types of processors, but also actuators with different types of controllers. And usually we can distinguish between two main modes, semi-automated or fully automated, depending on whether there is a human in the loop. Now move on to the next kind of areas, big data and machine learning, that have become very popular recently. What is big data? Well, growing large data sets that enable AI. I'm sure you may have read somewhere that big data is music to the ears of AI. The more data we have, the better the AI algorithm, assuming that data is reliable. On the developments in AI and these recent successes to another recent trend in terms of computational power that's been growing. So this wasn't possible maybe about 2 or 3 decades ago. We didn't have so large data sets and we didn't have this great computational power. But if we want to, for example, assess the complexity of a particular task we want to solve, again, we can use what some of you may be familiar with, the so-called big O approach to evaluating complexity, whereby we can have different type of complexity ranging from logarithmic, the lowest, to polynomial factorial, which are the highest. And in terms of big data, again, come across these 4 very important attributes: volume, velocity, veracity, and variety, which characterize different aspects such as the quantity and the size of the data, the way it's collected and processed, its quality and value, but also its type and nature. And machine learning has become really very popular recently. Some people even tend to use it as a synonym for AI, but it isn't. It is a very important part of AI, but not everything. So by machine learning, we assume that we've got autonomous learning by computers, mainly from big data, and I'll mention just a few main areas within machine learning, main challenges such as supervised and unsupervised learning, also how to choose train and testing data sets, first to train the model and then to evaluate it, testing systems for purpose. And also there are some challenges, for example, in terms of algorithm bias and variance, which could lead to what we know as model underfitting and overfitting to training data. So we need to try to find a trade-off between these two in order to allow the algorithm to generalize from fresh data, and there are different methods trying to do that, like data normalization and algorithm information, which is linked with AI, deep learning, and deep models. It's characterized by multiple building layers and multiple functional composition. As you can see on this picture for this particular neural network, we've got 2 hidden layers, the green and the red one, and we've got 3 kind of functions, the green, the red, and the yellow one in terms of bias. So when we compose these 3 functions, we end up with multiple functional composition. And that's just an illustration of, for example, where deep learning works well, example things, recognition, where it gradually goes into more detail, starting with edge detection and so forth. I have to say that deep learning has been inspired by what's been around and known as deep models. And they've been around for much longer than deep learning. I want to mention something about them as well. And by deep models, we mean enhanced modeling by gradual accumulation of more detailed information. There are 2 main types of multi-layer models, which implement what we call temporal decomposition, and multi-level models, which implement spatial decomposition. You can see 2 examples on the left for multi-layer models, and on the right for multi-layer models, and on the right for multi-level models. Where do we apply deep learning? Deep models in AI, again, first we can apply for different tasks like data collection and cleaning, or feature extraction and selection, or structure and parametric identification, or maybe for model refinement and finalization. And now I'd like to discuss very briefly performance evaluation, application areas, and some case studies. In terms of performance evaluation, you may have noticed more recently by reading academic papers that now people are more interested about more performance evaluation indicators, not just accuracy and efficiency, things like feasibility, transparency, stability, robustness, reliability, consistency, and others. And in terms of application areas, again, AI has been very successful for image recognition, segmentation, data clustering aggregation, and also fault detection diagnosis, and to some extent, for decision making and control. Some case studies, for example, using fuzzy system to capture uncertainty and intelligence when choosing routes for military convoys and naval ships, or neural networks analyzing flight data from recorders for preventive diagnosis during aircraft flight maintenance, or evolutionary algorithms exploring combinatorial problems in flight scheduling and aircraft logistics for airlines. So in other words, depending on the type of problem you've got, and you may choose one or other AI technique, and sometimes you may even combine two or three to get the best of both all worlds. Other case studies, like selection of players for football match and contestants for singing competition, maybe these will become more popular in the future. Recommendation for investment on stocks markets, or even voting political elections. I don't want to sound political, but I believe that AI had been used for the EU referendum, maybe the outcome could have been different. Current limitations, possible improvements, and main challenges. Current limitations of AI are for sensitivity to data quality, what I mentioned earlier, when there's noisy data. Dependency on computational performance, for example, if you need to implement it on a mobile platform that doesn't have, a good computing performance and capability. The black box context, which doesn't allow us to see what is inside the AI model. And also the reactive observation. AI has been mainly applied for reactive observation of the environment, but not too much for trying to change the environment for the better. And what are the possible improvements? Again, I've listed these in terms of these 4 bullet points, which relate to the bullet points from the previous slide, like data clean interpolation, the data compression reduction, the glass box or white box context, and proactive control. Some main challenges these days for AI, I'll start with interaction between humans and AI, how they interact, how different tasks are allocated, how they cooperate. And I just want to mention a few very important areas that have become very popular over the recent years. For example, interpretable and explainable AI, how to interpret and explain AI models. Also, responsible and trustworthy AI, how to make sure that we trust AI and it takes responsible decisions. Ethical and legal aspects of AI, again, just to make sure it doesn't discriminate on the basis of gender, age, race, and so forth. And I've mentioned here a few things which are even kind of more recent. Artificial reasoning is gradually complementing, learning. So in other words, maybe next years or decades we'll see more of this, whereby we've got machines that do not only learn from data, but can reason on the basis of what they've learned. Artificial wisdom, which is a higher level of AI, and again, which includes not only learning, but also reasoning. And something which may sound like something from the future or from AI movies, artificial consciousness. I still don't know if and when this could be implemented, maybe a long time in the future, but we'll have to wait and see. Just very briefly to mention some of my results. My main research results have been in, the research group I'm in fuzzy systems refinement by concepts from evolutionary algorithms and neural networks, in which case we try to improve model efficiency and transparency while maintaining accuracy and feasibility. And I've listed here 2 main areas of research. It's rule-based compression with some case studies like aircraft landing control and service center management, but also rule-based composition with some case studies like flotation process modeling and retail product costing. I won't bother to discuss these things in detail. We just kind of 2 slides explain conceptually these 2 main approaches, rule-based compression for fuzzy systems and rule-based composition in the context of fuzzy networks. And here on this slide, I just want to mention also my research collaborators from UK and other countries, and I'd like to highlight Professor Brian Kenneth from Solent University, Solent Computing, with whom we've had very successful collaboration over the years. It's there on the front row. And just to show a few kind of authored research monographs published over these main areas like machine learning, rule-based systems, fuzzy networks, complex systems, fuzzy systems, and so forth. Also also, just to show a few edited books, this one was authored by Professor Colin Penev, and I had the pleasure of being the editor of this book or research monograph, and some others published by Springer, Advances in Computational Intelligence Systems. And I'd like to show some popular textbooks written by others on related areas like artificial intelligence, computational intelligence, machine learning, and deep learning. And I'll stop here. I hope there is time left for questions and discussion. Thank you for your attention.
That's a fantastic from our keynote speaker. Has anyone got any questions? Yeah. Can you speak a bit louder, please? Yeah.
I have a quick question. Thank you for the presentation, by the way. So in your presentation, you mentioned that trustworthiness is a current challenge. But what advice would you give, or what would you say to robots and machines taking their jobs? People are worried about the impact of AI on
Yes. Okay, this is a more generic question. I'll try to give my view on that. About AI taking people's jobs. I think there'll be other jobs, maybe the green economy, that people can take, because the whole idea is AI takes jobs that are very difficult or hard to do for people. So it shouldn't be viewed as something which is an enemy to people, just on the opposite, that helps people. And maybe some people will be free to do other kind of activities, hobbies and other things, will have more free time. So that's my view. I'm very positive about that. Just people have to retrain themselves to take other jobs to become available. In terms of people maybe being scared of AI, what may happen again, I think AI is not to blame. If there's someone to blame, it is the people who develop AI algorithms, and not the AI algorithms. So we have to make sure that they kind of stick to these kind of principles of responsibility and trustworthiness. And many prestigious organizations like NATO and European Union have already published some kind of policies on how to use and develop AI in a responsible way. So that's my answer to your question.
Got another question?
Yeah, thank you, Alexander, for the presentation. Excellent information there. I noticed that one word was particularly missing from your presentation, and that was risk. Did the risk and the assessment of risk play a big part in a big challenge for AI?
Just to clarify, do you mean the risk from AI or using AI to assess risk? Can you clarify your question?
AI
To assess risk, yes. Yes, I think that this is an area where we can use AI, and I happen to know something about that. I've been more recently involved in collaboration activity with different organizations within NATO. So we've been working on trying to assess risk during different types of operations and missions undertaken by NATO, which could affect not only military personnel but also the civilian population. And we are trying to explore AI and how it can and help kind of reduce this risk, or assess this risk better. So, yeah.
Thank you. Yeah, question for you.
Hi, thank you for your presentation. I just want to know your opinion about effect of AI on cognitive of humans, or decision making. So there are instances, especially in the learning community. So there are instances where AI is used to assess grades, or to assess assessment, to assess individuals, their work. So do you think the impact of AI reduces or affects our decision making? So in the sense that if in the US, for example, there was this situation where a student got 100% in their essay, in the sense that the student used AI to actually write a particular essay. and then AI was now used to grade essays. So I tried to explain that particular student got a higher grade compared to those that actually use their knowledge to write it. So my question is, do you think AI affects individuals, or going forward, will it affect our cognitive and decision-making
Feature assessment.
Yes.
Yeah, briefly speaking, yes. AI has been used, or will be used for I would say maybe decision support.
Yeah.
Maybe in the future also decision making if it becomes really trustworthy enough. But for the time being, I think in most cases it's only used for decision support. It should be used only for decision support, whereby the humans should make the final decision based on the recommendations given from the AI. But again, I just want to reiterate my answer to one of the previous questions. I mean, it all depends on who develops the AI, and we have to make sure that the AI is unbiased and is ethical, and it doesn't discriminate on any grounds. It doesn't favor anyone, disadvantage others, and so forth. So maybe that's my answer to your question. You have to be careful about that, and we need still to have a human in the loop to make the final decision at this stage.
One final question. We've got about 2 minutes. Yeah.
I saw a traditional regulatory control system.
Yes.
I wanted to find out both that AI has actually improved on these systems.
Yes, I understand. Let me just see if I can find it, because I know what you refer to. Yes, example one. Yes. Well, there are many ways in which you can somehow incorporate AI. For example, you can use a neural controller or fuzzy controller or neural fuzzy controller, for example. That's one way, in the controller. Or you can use some kind of intelligent sensors in the process, which process the data and so forth. So just 2 examples. So you can use AI in different aspects of this control, in different places of this control.
Thank you.
Okay, I'll say we want to thank our first keynote speaker. Thank you for